everyone, welcome to the chemistry channel. So in this video we're going to be talking about enthalpy and where the enthalpy equation comes from. So this is the enthalpy equation. So note that this video is most likely not going to cover material that you need to know for a general chemistry class. However, and I'm going to be showing this equation in a future video as well as all the implications by it. The only thing that I'm doing in this video is showing you where this equation comes from. So if you're curious, watch it. But if you don't really care and you don't need to know this, feel free to not watch this video because it's going to have some calculus in it. So with that, let's begin. So let's begin with our first law. And we're going to substitute in our work equation. And we're going to assume a reversible system. And what we're going to do now is solve for dq. So we're going to solve for this. So dq is equal to du plus p dv. Then what we're going to do is we're going to integrate, and we're going to assume that it's under constant p, because that's what most chemical reactions are under, constant pressure. So dq is equal to the integrated du, when we're going to put our upper and lower bounds, plus p dv. And when we do this, we get Q is equal to delta U plus P delta V. So what do you notice in this equation? Well, in this equation you have three state functions. U is a state function, pressure is a state function, and volume is a state function. These are all state functions. Since we have all three state functions, we can define a new state function. And this new state function is going to be called enthalpy. And enthalpy is given the symbol of H. So H is equal to U plus PV. Now we're going to differentiate this equation. So when we differentiate this equation, we get dH is equal to du plus P dV plus V dP. Now we're under constant P, or constant pressure, so therefore this term goes to 0, giving us dH is equal to du plus P dV. And when we integrate this, H1, H2 is equal to du U1, U2 plus P dV V1, V2, because we're in constant pressure. And since we're under constant pressure, we can now integrate this. So delta H is equal to delta U plus P delta V. And this is the enthalpy equation. So you'll notice here that delta H is equal to Q under isobaric conditions. So delta H is equal to Q under isobaric conditions, and this is most conditions. So therefore, when heat is lost by the system, Q is negative, therefore delta H is negative. And when delta H is negative, this means that heat is lost by a system and the process is exothermic. And when heat is gained by the system, Q is positive. Therefore, delta H is positive. And this type of process, when heat is gained by the system, is called an endothermic process. And we're going to get more into this in a later video. So with that, I thank you for going through all this calculus with me. And in the next video, we're going to reiterate this equation, and we're going to also reiterate the consequences of it. And we're going to be talking about, I think, delta H of reactions. So I thank you all for watching, and I hope to see you next time.